In this video, we're going to explore some advanced C# principles and practices. They're not too specific to Unity. They're more speaking about language features themselves. Here and there, I might mention something about how it applies to Unity. So I've broken it into a couple different sections. We'll first start out with some class-related issues. And for each of these projects, the scene itself is pretty bare. There's typically just something like what we see here, C# classes, and it's inviting you to press play, look at the output console on the right, and then press stop. In each of these examples, it's much more important to look at the C# code that's being executed than to really look at the scene or the game view. Also, in some areas, I might skip a section of what a class file is talking about. Really, you'll get the most benefit if you dig into the code yourself. So downloading the source and looking at it yourself is the best next step. But here we'll just go through the highlights and take a look at each issue. So if I look at each scene here, inside the folder of a topic classes, there's the scene itself, then a similarly named class file, which in each case is on the manager's game object, and it's just an empty game object where I've got that code executed, which is the hack in Unity to get code to execute when you click play. Then inside a scripts folder, if the lesson needs to have some more scripts like this one does, I put them all in there. Then when we get to the topic of scope, it's dealing with a different Unity scene, a different manager game object component class, and then a different set of scripts. So they work in isolation, each one. So first, let's take a look at just the topic about classes. So if I go ahead and give it a run, we see quite a bit output here. Information about partial, interface, downcasting, upcasting, singleton, struct. And I invite you to take a look at each of those. I'm just going to talk about a few of the highlights. So let's start jumping in MonoDevelop. And MonoDevelop shows us the same tree structure of class on the left in the solution panel. And for most of these, I'm going to double click on the tab so that we can see the code a little bit larger. Adjusting my screen a little bit. We'll come down here and we'll see, similar to the previous lessons, we've got a separate method and some commenting that helps us see in the output each section in isolation again. So we'll talk about partial classes, and then I might jump in and talk about a few of these other issues. Some I might just let you jump in. There's also a really nice value here for you just to see a consistent example of each of these, both in this lesson and other lessons. So even if I don't explain something like struct, let's say, if you're interested in how a struct could be set up, this gives you a nice project to just jump right into a working example, see it run with no errors, and then you're able to start coding on top of that and fool around a bit and learn that way. So I invite you to check it out for that reason as well. All right, so looking at partial class, in some of these I link to somewhere online where you can find some more information about it. What I thought was a really interesting feature of C# is what is called partial classes. And that is, if I jump into the declaration by right-click and go to declaration, you can see that there are two classes, not just one, two class files that define this, which is the first time I've seen that. That might exist in languages that you're coming from, but for me this is new. And you've got two different text files that help to define what this is. You can see one that's highlighted is partialclass.cs. The second one is partialclass.more.cs, and I think you can do as many as you want there. What the compiler does is it looks for similarities in what you've declared up here. Sorry, let me jump into one. Sorry. So partial class, so it's looking for this partial flag. If we jump over to the other one, it's got the partial flag, and it's both of them are named class. And then that combined with the naming of the file, text file itself, allows us to define method 1 and method 3 in one file, and method 2 in another file. And then from this outer file that's taking advantage of all this, I can call method 2, method 3, and it's as if those two different text files are baked together at compile time. Now, why would you want to do this? I think most of the documentation, including the link there, it explains it's probably not something you want to do as during manual software development as you're typing and creating the class yourself. But if you have some sort of code generation as part of your workflow, maybe you are doing communication with the server and that requires some automation that is generating some of your client-side code, or I'm not sure what other instances it might pop up. But maybe you let the human-written code go in one of the class files and the machine-generated code generation go into another one. I could also imagine in workflow it might become useful for another reason. Could also quickly become confusing too, but I just wanted to throw that in there because this was something that was very new to me from other languages that I'm familiar with. Then here's an example of using an interface. So the hand mixer is being cast here as an eye mixer, and just taking a quick look at that. Inside hand mixer, where you typically say what it extends from, I do extend from something, but then comma, I also give an interface, and an interface, which you're probably familiar from other languages, defines the public API to the class, but doesn't include any of the implementation. So an interface is just a promise to the compiler that, yes, I will use a method called doMixing somewhere in my implementation. Right? And that's very useful, and there's lots of good reasons to use interfaces, and you can Google to research more about that. Then inside casting, I've got an example of downcasting and upcasting. So casting is when here I have an electric mixer instance typed as a mixer class. So typically you might see something like this, where the electric mixer instance is typed as electric mixer. That's usually the default that you might start with as you're developing. But you might want to have it instead typed as its superclass, in this case mixer. And the comments explain a little bit about that. Then there's what is called upcasting. And upcasting is where you take a hand mixer and here you have it act like a mixer. Here is the downcasting part. So in the comments it explains a little bit about what upcasting and downcasting is, and there's an explanation for each one. Singleton I use quite frequently in this series, whether I've talked about it explicitly in the video series or not, but we will get to a single, what do I call it, single game manager, a simple game manager in this future video where I'll talk more about singleton. But here's an example of where you can use a singleton and how you set that up. Then there's a struct. Struct is kind of like a class, but there's some interesting differences between what is a class and what is a struct, and you can see a little bit of opinion that I found and some references there. And there's a demo of the struct as well. So that's it for that first lesson. Now let's talk a little bit about scope. So scope, we open up the scene, give it a run. You can see the output here. And as you're going through these yourselves, you might want to tweak some of the source code, rerun it, look at these results, right? But I'm just giving a briefer overview here. So we've got the basic scope, namespace issues, and then I take advantage of ref and out, which are something, again, new to C#, new to me. They're parts of C#. So I wanted to call out both of these because I hadn't used them before in other languages or something similar to them. So let's take a look. So jumping into the source code here. So scope as a general issue is talking about where a variable is accessible, or where any code structure is accessible, but a variable would be an example. So of course, if I at the top of this script have sample private int declared and a public float, from anywhere within that class file I can access a private and a public, right? Then I can create local variables, of course, like I declare it on 111, I use it on 112, then maybe I never use it again, right? It's local to the scope of from 104 down to line 125, right? So it's more limited. If you want to access something from outside of this class, one option is public, right? So in sample public float, I could access that here. In 108, I could access it from some other class, etc. Then taking a look at namespacing. So namespacing is optional within Unity, and when you're creating your classes, you don't need to define a namespace, which I was surprised about, especially with the C# language choice. There's also within Unity, you can use Unity script, which is JavaScript, or another called Boo. And those are less conventional and have less requirements about how you use them. So I wasn't surprised namespace wasn't required there, but I was in C#. So C# continues to be continues not to require that you use namespaces. So I have a class here called namespace class. And if I look at the declaration of it, the class declaration starts with a namespace declaration. So inside the namespace, which you could think of like a virtual folder that holds this class. Then in order to access that atop this script, just like I use the Unity engine namespace, system, some of these other ones you might be used to adding using, I must do using custom namespace as well. If I don't, then when I try to compile here, I'll get an error. It'll say the class namespace can't be found anywhere. And that's because it's hidden, so to speak, inside a folder, you could think of it, or a system of organization. And the reason you might do that is because you want your code to be, you want a user to be able to specifically access some of your code, but not others. And that can prevent naming conflicts and some other issues. It's also just a good system of organization. In my projects, my preference would be to use namespaces across every class file I define, but your team might work a different way. But there's an example of how to declare that and how to use that here. So I put that line back and we build successfully. Then I'll just explain ref, because out is pretty much the same thing. That if I want to pass in an array, and within the class I want to actually affect a value, and then after the call I want that value to persist, you can use out and ref, and you would declare ref in when you're passing the parameter, and ref again when you're accessing that argument that comes in. So you can think of this as forcing a pass by reference instead of the default pass by value. And you can look up those two terminologies, pass by value and pass by reference. Out is very similar, except out allows you to pass in a reference. Oops, that's actually something I've written for both of them. So this doesn't describe the differences accurately, but let me go up here and see if it here. Yeah, so the difference is that when you use out, you do not need to instantiate the object before you pass it in. So here, I don't say equals new list of string, because the out parameter modifier there is saying, okay, I don't care if it's declared or not in 209 and defined. I will just take the pointer, and we can actually do the declaration inside. And architecturally, there's reasons you might want to do each one of those, giving more responsibility here to accept instance by out. Using out, it needs to do line 229 and line 230 in order to be useful. Let's see if we got something else. Nope, that's it. Burning along here. So next we're going to take a look at conditionals. Go ahead and give it a run. So this isn't an advanced topic at all, but just for completeness sake of covering C#, I wanted to explore and have a place for me to show off very simple things using an if statement and using a switch statement. So if statement is a no-brainer. If that is new to you, then you can take a look at an example. And switch statement could be new depending on where you're coming from in your background, and maybe you're not used to using the default syntax here. So both of them are explained there. and the comments show. I'll skip it for most of us because it is pretty common across languages. Same thing with this loops. Go ahead and run the loops example, and we've got looping through while, do while, for loop with a break, for each loop, and let's take a look at the source. So these are just ways to iterate through a list of data. So you can take a look at each one of these samples, and probably the syntax is the same in the language you're coming from, depending, but there's a good example for you for each one. Lastly, let's take a look at collections. So I'm going to go ahead and give a run there. So we've got array to list, list to array, hash table, dictionary. So this is just a little bit about, in the last example, looping through arrays. These collection data types are something like an array. They're a list of values, but with some more robust functionality built into them. So we've got converting from an array to a list and from a list to an array, which is very common in Unity development. You'll need to do those. Then the use of hash tables and dictionaries, that's more of a custom implementation that you might want to use in your Unity project or other C# project. So there's examples of those. I don't think there's anything I wanted to mention. Nope, but feel free to take a look at that. So that's all for the first of the videos specific to C# and advanced techniques. So you see a few of them were more advanced than others, but in the following video we're going to take a look at some stuff that builds on that too. So I wanted to show everyone examples that work well, no errors, good syntax, good consistent naming based on the naming schemes that I use for my project setups. And that's it. Thanks.